Introduction. Let's play a game. There is a prize for the student who first searches where I have hidden the box of chocolates. Sir, but how do we search for it? Are you giving us any hints? No, Saga. There will be no hints. You have to find out on your own. Do you think it will be easy? The entire class will keep searching for it, and this would lead to chaos. Sir, I don't think so. Sagar, you are correct. Similarly, when elements were discovered, there was a chaos. Let me tell you about this in detail. Children, in this lesson, we will learn about the basis on which elements are classified. Objectives. At the end of this lesson, you'll be able to describe the early attempts at classifying elements, explain Mendeleev's periodic table, explain the modern periodic table. Early attempts at classification of elements. In the early days, scientists classified elements purely on the basis of whether they were metals or non-metals. This had its own limitations. All elements were grouped in only two categories. This made the metals category very big. Some elements had the properties of both metals and non-metals. They could not be placed in any of the classes. This increased the need to identify some kind of pattern or regularity in the properties of the elements and then classify them. Dobereiner's Triads. In 1829, Dobereiner, a German scientist, made groups of 3 elements, each based on their properties. He named them triads. He observed that atomic mass of the middle element of a triad was equal to the arithmetic mean of atomic masses of other 2 elements. For example, in a triad of calcium, Ca40, strontium, Sr88, and barium, Ba137, the mean of the atomic masses of the first and third elements is equal to the atomic mass of the second element. That is, 40 plus 137 whole upon 2, which is 88 mu. Did you know? The German writer Goethe was a friend of Dobereiner. He attended his lectures weekly and used his theories of chemical affinities as a basis for his famous 1809 novella, Elective Affinities. Newlands Law of Octaves. Dobereiner's research simultaneously encouraged other scientists to start classifying elements. The triads were not useful as they could classify only 3 elements at a time. In 1864, John Alexander Newland, an English chemist, discovered that when elements are arranged in the increasing order of their atomic masses, atomic weight, every 8th element had properties similar to the first element. This is called the law of octaves. However, all elements could be arranged in this order only till calcium, even though there were more than 60 elements available at that time. Did you know? Like other scientists, Newlands used the terms equivalent weight and atomic weight without differentiating the words with their meaning, and in his first paper in 1863, he used the values accepted by his predecessors. This term is now referred to as relative atomic mass. Mendeleev's periodic table. Dmitri Mendeleev, a Russian chemist, discovered that elements, after arranging them in the increasing order of atomic mass with similar chemical properties, occurred periodically. In 1869, he stated this observation in Mendeleev's periodic law. He also discovered that a periodic function repeats itself after a certain interval. Hence, according to the periodic law, the chemical and physical properties of elements repeat themselves after certain intervals when they are arranged in the increasing order of their atomic mass. A tabular arrangement of the elements based on the periodic law is called periodic table. Mendeleev arranged all elements in their increasing order in horizontal rows till he encountered an element that had properties similar to the first element. He placed this element below the first element and thus started the second row of elements. This helped him to arrange all the known elements according to their properties. He was thus able to create the first periodic table. Features of Mendeleev's periodic table. Mendeleev's periodic table has the following features. The horizontal rows represented in the periodic table are called periods. There are 7 periods in the periodic table, numbered from 1 to 7. Properties of elements in a particular period show regular gradation from left to right. The vertical columns are called groups. These groups are 9 in number and are numbered from 1 to 8 and 0. Groups 1 to 7 are further divided into A and B subgroups. Groups 0 and 8 do not have any subgroups. All the elements in a particular group are chemically similar. They show regular gradation in their physical properties and chemical reactivities. Defects of Mendeleev's periodic table. Mendeleev's periodic table had certain defects. They are listed below. Hydrogen could neither be placed with alkali metals nor with halogens, as hydrogen resembles alkali metals as well as halogens. Different isotopes of same elements have different atomic masses. This need to be taken into consideration, and each one of them should be given a different position in the periodic table. However, because they are chemically similar, they had to be given same position. At certain places, an element of higher atomic mass has been placed before an element of lower atomic mass. For example, argon 39.91 is placed before potassium 39.1. Did you know? Mendeleev studied petroleum origin and concluded that hydrocarbons are abiogenic and come from deep within the earth. He wrote, "The capital fact to note is that petroleum was born in the depths of the earth, and it is only there that we must seek its origin." The modern periodic table. Henry Moseley, an English physicist, in 1913, discovered that the atomic number is the most fundamental property of an element. Atomic number of an element refers to the number of protons in the nucleus of its atom. The number of electrons in the neutral atom is also equal to its atomic number. This led to a change in the periodic law. The modern periodic law states that the chemical and physical properties of elements are a periodic function of their atomic numbers. Position of elements in the modern periodic table. The most commonly used periodic table is the long form of modern periodic table. Let us look at some features of the periodic table. Groups. The periodic table has 18 columns. These columns are called groups. The extreme left elements of the group contain alkali elements, and the extreme right elements contain noble gases. All elements in the group have similar electronic configurations and have the same number of valence electrons. Periods. The 7 rows in the periodic table are called periods. In each period, a new shell fills up. The period number is also the number of shell which starts filling up. Trends in the modern periodic table. Valency. The valency is calculated by the number of valence electrons present in the outermost shell of its atom. The number of valence electrons increases in a period. Atomic size. Physical properties like density, melting, and boiling points relate to the sizes of atoms. The atomic size is very difficult to define. However, the atomic radius helps in determining the size of an atom. Metallic and non-metallic properties. The characteristics of metals are its electropositive character, which means the tendency to lose electrons, metallic luster, ductility, malleability, and electrical conductance. The metallic character of an element depends upon the ionization energy it generates. The smaller the value of ionization energy, more electropositive and more metallic the element would be. Summary. Let us summarize what we have learned. Scientists classified elements based on metals and non-metals. Dobereiner identified elements with similar properties and arranged them into groups called triads. Newlands arranged the elements in the order of increasing atomic masses. This is the law of octaves. Mendeleev created the periodic table and classified elements based on elements were arranged on the basis of the atomic mass. Moseley created the modern periodic table where the elements were further classified based on the atomic number of an element.